We have seen that conditional probabilities may come in handy when calculating probabilities of intersection of two events. So if you're looking for probability of intersection of A and B, this might be expressed as conditional probability A given B multiplied by probability of B, and also as conditional probability B given A multiplied by probability of A. Now, in the case when we have intersection of more than two events, let's say intersection of three events, we might consider an intersection of A and B as a single event, let's call it D, and express that as a product of the following conditional probabilities, C given D, multiplied by probability of D, which is probability C given A intersection B, multiplied by probability of A intersection B, which in turn might be expressed as B given A, multiplied by probability of A. In the case when we have intersection of more than three events, let's say an intersection of n events, AIs of AIs from A1 through AN, then we might apply the same principle as we did here, and let's say call the first n-1 event as a single event and proceed as follows. So we have probability AN given intersection of this n-1 events. Multiplied by probability of intersection of first n-1 events. All right, from here we might apply the same step as we did here and call this n-2 events now as a single event, and we'll have the following product. Multiplied by probability, 1 second, so multiplied by probability of intersection of AIs from 1 to n-2. All right, now again applying the same step for this intersection here and following through, we finally might get to the following result. Probability n-1 given intersection of AIs from n1 to n-2, and so on, up until we get probability of A2 given A1 multiplied by probability of A1. All right. Now, let's take a look at the following problem. So we have an urn that contains 5 white, 4 black, and 3 red chips. 4 chips are drawn sequentially and without replacement. What is the probability of obtaining the following sequence? White, red, white, black. We are looking for probability of intersection with the following events. Intersection of white on first row, red on second, white on third, and black on last row, and without replacements. So if we draw a white on our first row, then we'll end up with the following order. We'll end up with 4 white, 4 black, 3 red chips. Now, if we draw red on a second row, given that we have drawn white on the first, we'll end up with the following order: 4 white, 4 black, 2 red chips. Next, if we draw a white on our third row, given that we have drawn red on second and given that we have drawn white on first, we'll end up with the following order, where we have 3 white, 4 black, and 2 red chips. And if we draw black on our last row, finally we'll end up with the following order: 3 white, 3 black, and 2 red chips. Now we are looking for the following probability. Probability drawing white on first, intersection with red on the second row, white on third row, and black on fourth row. This might be expressed as the following product using the principle we studied here. Probability of drawing black on last row, given that we have drawn white on first, red on second, white on third row. We know that probabilities, since this is the same as drawing black chip out of an urn, which was brought to this state here by drawing white on first, red on second, and white on third row. So this is equal to 4/9. Multiplied by probability of drawing white on third row, given that we have drawn white on first and red on second. We also know this probability here. This is simply drawing a white chip out of an urn, which was brought to this state here by drawing white on first and red on second. So this is equal to 4/10. Multiplied by probability of drawing red on second, given that white was on the first draw. So this is the same as drawing red chip out of the second urn here, which is equal to 3/11. Multiplied by probability of drawing white chip on the first draw, which is simply drawing white chip out of this urn here, and it is equal to 5/12. So the answer is 4/9 multiplied by 4/10 multiplied by 3/11 multiplied by 5/12.